Hello and welcome to this presentation on predicting chemical reactions, which is C4.1. So group 1, which are the alkaline metals, are the vertical column on the far left of the periodic table. And they're called the alkaline metals because when they react with water they form an alkaline solution, which is usually a metal hydroxide. And then they're shiny when they're cut, and they also conduct electricity, but unlike most metals, they can be cut with a knife, so they're quite soft. So as you go down the group, they get softer, more reactive, and their densities increase. Apart from sodium has a higher density than you would expect looking at the graph. So this is an example reaction between sodium and water, and it produces sodium hydroxide and hydrogen. So when you react lithium, it fizzes and slowly disappears. Sodium is a bit more reactive, so it melts to a silvery ball, fizzes vigorously, and quickly disappears. And then potassium, which is even more reactive, ignites immediately, burns with lilac flame, and disappears very quickly. And then going further down, they're even more reactive, but generally, you don't need to know them because they're very unsafe to do. So why do they get more reactive? It's because group 1 metals have similar properties as well. It's the same thing because they all want to lose the one electron that they have on their outer shell. So then they can have a full outer shell, which is very stable. So the easier it is for the alkaline metals to lose the electron, the more reactive it will be. So therefore, potassium is more reactive than lithium because it loses its outer electron more easily. And then there's group 7, which are also known as the halogens, they exist as diatomic molecules with weak intermolecular forces. For example, chlorine exists as Cl2. And they react with metals to form salts or ionic compounds. And there's a few of the halogens. As you can see, they're in lots of different states. So as you go down group 7, the density increases and the melting and boiling points increase as well, which is why as you go down, they turn into liquids and then solids in iodine. But the reactivity actually decreases as you go down group 7. So fluorine is the most reactive. So why does it decrease? It's because each halogen has 7 electrons on its outer shell. So it wants to gain 1 more electron to get 8 electrons and a full outer shell. So the easier it is for it to gain an electron, the more reactive it will be. So fluorine is more reactive than bromine because it gains an extra electron more easily. And then there are halogen displacement reactions, which is where, so if you get 2 halogens, for example, fluorine and bromine, and the bromine is a halide ion in a compound, and a halide ion is basically an ion with a 1- charge, which is a halogen. So if you had, let's say, sodium bromide and then added fluorine, the fluorine would displace the bromine in the compound. So you would get bromine and sodium fluoride because the fluorine is more reactive. Then you have group 0, which is the noble gases, not group 8, group 0. You can't call it group 8. You can call it group 18 actually. But anyway, they're very unreactive. There are a couple of reactions that some of the ones lower down can do, but even then it's only with fluorine and possibly chlorine. So generally we just say they don't react. They're all non-metals and gases at room temperature. And the reason why they don't react is because they have full outer shells, so they're already stable. They have no need to try and get rid of gain electrons to get a full outer shell. And then they're monatomic, which means it's just one of them in each molecule, except it's not a molecule, it's just an atom. when you compare that to diatomic, where there's 2 of them. And they have very weak forces of attraction between them. Ignore the typo. So as you go down group 0, the boiling point increases, but it's still very low, usually so helium is about negative 260 degrees Celsius. And they do increase up to about 50 for xenon, but still gases. And also the density increases as you go down group 0, but again, the density is still very, very low. So the transition metals are all shiny, they're good conductors of electricity, they're strong and malleable, but compared to group 1, they are stronger and harder, and they have higher densities and higher melting points. And generally the transition metals are what you think of when you think of a typical metal, such as iron, silver, gold, copper. So they react slower than group 1, if they react at all. So some of them hardly react at all. For example, gold does not react with air or water at all. And they can form ions with different charges. For example, iron can form an ion with a 2+ charge or a 3+ charge. And the compounds they create are many different colours, like iron 2 is green, copper's blue, just for a couple of examples. And they're often good catalysts. And a catalyst is something that increases the rate of reaction without being actually used in the reaction. So the reactivity of metals, any metals with water, can be used to put them in an order, and that order is called the reactivity series. So if you get a more reactive metal added to a compound with a less reactive metal in it, it will displace that metal in the same way a more reactive halogen will displace a less reactive halogen. So, for example, here copper will displace silver if copper is added to silver nitrate. So how do we predict reactions? We try and predict them using the facts we know, such as the elements in group 0 don't react. Like group 7, the reactivity increases up the group. So therefore, you know, if you're adding chlorine to iron bromide, the chlorine is going to displace the bromide. So this is one way that we try and predict reactions. So yeah, that'll be the presentation. Thanks for watching, guys. See you on the next video.